So now I'm just adding more tapered roller bearings for the output drive. I don't actually know if I need the second bearing. The guys at 74 Weld put a big snout on the end of it, and I don't know if they use a bearing on that snout or if they just grease it, but theoretically there would not be any load on that part of the output gear because you have one bearing on the outer shell of the portal box, and then you have another set of bearings and the unit bearing on the wheel. So there's your two constraints. I just added a third one because I had room for it and it looked stronger. And then on the input gears and the idler gears, what I'm realizing now is that I have the wrong diameter on there. It was 4 inches, but it was supposed to be 4.5. But I'm going to end up with a 3-inch OD bearing to capture both of these. And I need to make sure that the groove is the right height. So luckily I had enough room. I'm assuming a 1.5-inch input shaft on the axle. And then there's plenty of clearance there for the bearing to go in and capture the input and idler gears. So again, adding that tapered cut on the resolve and making sure that everything matches. And then SolidWorks is crashing, but we're okay. And so now I'm adding another bearing on the outer side of the tall knuckle because this input gear is going to have a really, really long shank to it because it has to go all the way from the center of the wheel to like 8 inches out inboard. And I need to constrain that part of the shaft because this is basically the drive input shaft. Whereas the idler gears, they're a lot simpler. They're just housed in the box. The only force on them is torque, and there's no radial or lateral force on them. So those can be, oh yeah, now I'm realizing I got the wrong diameters here. So I got to fix those. Wondering why those tangents don't match. I made them 4 rather than 4.5. There they are, 4.5. Increasing the diameter on those, double checking all of my gear teeth dimensions to make sure I have enough clearance.